everyone, welcome to Sri Chaitanya. This is Umasankar, IIT coordinator. Welcome to VECTORALGEBRA lessons. So far successfully we have completed 10 lessons in VECTORALGEBRA. From lesson number 7 and 8 we have concentrated the dot product of the vectors, and lesson number 9 we concentrated the vector product or cross product, and lesson number 10 we concentrated on the scalar triple product. Now through this lesson we are concentrating the vector triple product. After a scalar triple product, vector triple product is very another important and challenging part of the vector algebra. And again, my friends, please don't forget to check the description. There I'm providing very good lessons and assignments along this video and links of the previous lessons also. Through this lesson today, we are concentrating the basic definition, properties, and geometrical interpretation of the vector triple product and the language and fundas involved in vector triple product, mainly Li and Ld, linearly independent and linearly dependent. And another important point is fundamental theorems on space. And of course, we are introducing the conditions for coplanarity and reciprocal system of vectors. All are very important. Theoretically, problem point of view, problems are guaranteed from this particular area. Now coming to the definition of vector triple product. If A bar, B bar, C bar are any three vectors, then A bar cross B bar cross C bar is called a vector triple product. Why it is a vector triple product? Because B bar cross C bar is a vector and cross product with A bar is again a vector. So this is called what? Vector triple product, because three vectors involved. Okay. And what is the geometrical interpretation of A bar cross B bar cross C bar? Actually, you know that A bar cross B bar. What is A bar cross B bar? Suppose this is A bar and suppose this is B bar. Then A bar cross B bar is the vector which is perpendicular to both A bar and B bar. That is, it is always perpendicular to the plane of A bar and B bar. Now, what is about A bar cross B bar cross C bar? You imagine. So, just in the place of A bar cross B bar, you imagine A bar cross B bar cross C bar. So what does it mean? So it is this expression A bar cross B bar cross C bar, which itself is a vector. Since it is the cross product of the vectors A bar and B bar cross C bar, so this vector A bar cross B cross C is a vector perpendicular to A bar and B bar cross C bar. But B bar cross C bar is vector perpendicular to what? B bar and C bar. Therefore, A bar cross B cross C is a vector which lies in the plane of B bar and C bar. This is very and perpendicular to A bar. This is very important. Based on the last three lines only, entire cross product of three vectors depends. So what do you mean by, if anybody is asking you what is A bar cross B cross C, immediately tell that and give the explanation like this. It is a vector, and it is a vector. It is lies on the plane of A bar, B bar and C bar and perpendicular to A bar. What can you say? It is the vector lie on a plane of B bar and C bar, and perpendicular to A bar. So imagine a vector which is lie on the plane of B bar and C bar and perpendicular to A bar, then that is nothing but A bar cross B cross C. So it may be like this. Suppose it may be like this. Suppose this is B bar and C bar and this is the vector like this. Suppose this is A bar and this is B bar and C bar. This is what? A bar cross B cross C. It may be like this. It may be like this. So it is what? It lies on in the plane of B bar and C bar, and it is perpendicular to A bar. So you imagine that kind of. That means A bar cross B cross C is coplanar with B bar and C bar. That means A bar cross B cross C and B bar and C bar, they are what? Coplanar. This funda is again important, my friends. That's why this is the vector, it is coplanar with these two. Whenever a vector is coplanar with the remaining two vectors, this can be expressed as a linear combination of these two. Several problems can be solved in vector algebra with this fundamental. Please practice this line. Since it is the vector or A cross B cross C and B bar C bar are coplanar. So one vector can be expressed as linear combination of another two. That is the original statement. So conveniently what I am saying is this vector A cross B cross C can be expressed as a linear combination of B bar and C bar because they are what? Coplanar. That means A cross B cross C is equal to X B bar plus Y C bar, where X and Y are scalars. And how to find A cross B cross C? Because how to find A cross B dot C or A dot B cross C? That is box, that is determinant. Here, how to find A cross B cross C? This is A dot CB and B dot CA. First, A dot CB. So, extremes. So, A cross B cross C. How to find A dot C? First, A dot C. This is A dot C, B immediately. Please don't write any dot or cross product between the minus. Next, A dot B. A dot B, C. This is the way to solve. This is the way to apply. Here, C dot A, C to extreme. What is extreme to C? A. C dot A, B to C dot B, A. So, this is easy way to write the formula without any confusion. And moreover, A cross B cross C not equal to A cross B cross C. This is again an important concept. Questions were repeated based on this. Okay, my friends. Now coming to the linear combination or linearly independent and dependent of vectors. See, as I said, suppose if any vector which can be expressed as suppose say if A bar, B bar, C bar or something, there's a set of finite vectors, then this relation X A bar plus Y B bar plus Z C bar and so on. This is what a vector, let it be R bar. Then we can say that R bar can be expressed as a linear combination of the finite set of vectors A bar, B bar, C bar, where X, Y, Z all are what? Real numbers. This is called, the way to express this kind of expression is called linear combination. It is called what? Linear combination. Suppose my A bar is equal to 1, 0, 0 and B bar equal to 0, 1, 0. C bar equal to 0, 0, 1. Suppose my R bar is equal to 1, 2, 3. So I can write my R bar as R bar is equal to 1 into A bar plus 2 into B bar plus 3 into C bar. Sorry, please don't write any dot or something. So 1 A bar plus 2 B bar plus 3 C bar. Because what is 1 A bar? 1 A bar means what? 1 into 1, 0, 0. That means 1 into 1, 0, 0 means 1 into I plus 0 J plus 0 K plus 2 into 0 I plus 0 J plus 0 K plus 3 into 0 I plus 0 J plus K. Like that. So what I did, I have been expressed, or R bar has been expressed as a linear combination of A bar, B bar, C bar. There 1, 2, 3 are what? My scalars. Like that kind of relation is called expression of that vector as a linear combination of the given vectors. Okay, what is fundamental theorem in a plane? Suppose if A bar and B bar are non-zero, non-collinear vectors. See, if I am talking about two vectors. Whenever I am talking about two vectors, I need to say whether they are collinear or not collinear. So here A bar and B bar are non-zero and non-collinear vectors. Then any vector R bar can be uniquely expressed as linear combination of A bar and B bar. That means there exist unique scalars. If anybody finds X and Y, everybody should get the same values. That is called the uniqueness. So for any two non-collinear vectors, there exists a linear combination that should be unique. That means you will find unique scalars X and Y such that R bar is equal to X A bar plus Y B bar. This is what the fundamental theorem in a plane. This is what about if I am talking about two vectors. If I am talking about two vectors, I am focusing on the collinearity. Suppose if I am talking about the three vectors, I am concentrating on the coplanarity. Suppose if A bar, B bar, C bar are non-zero and non-coplanar, see, more than two vectors whenever it is given, don't use the term collinearity because two vectors are always coplanar. So three vectors. If any vector R, if they are three non-coplanar vectors. See, this is the very fundamental important theorem. In advanced examination, questions were repeated based on this theorem only. If whenever you are finding three non-coplanar vectors are given for you, then you can express any vector, a uniquely expressed with linear combination of that three vectors A bar, B bar, C bar. That means you will find three scalars, unique scalars. So everybody should get the same values, not a different scalars, arbitrary scalars, unique scalars, so that R bar equal to X A bar plus Y B bar plus Z C bar, you can write it. This is called fundamental theorem in space. This is about coplanarity, non-coplanar vectors concept, and previous one is what? Non-collinear vectors concept. Okay. Now, when can I say the vectors are linearly independent, and when can say that I say the vectors are linearly dependent? So, linearly independent and linearly dependent fundas are applicable only for vectors, not for other things, not for points. So, the set of vectors are said to be linearly independent. You consider any linear combination of this form such that each and every scalar equal to same, or each and every scalar equal to 0. Suppose you consider any linear combination, that means k1 x1 bar plus k2 x2 bar and so on plus kn x1 bar equal to 0 bar, you consider, and you proved that all the scalars are equal to 0, then simply the set of vectors, you can say that they are linearly independent. See, if you are considering any set of vectors, only two choices are will be there, whether they are linearly independent or linearly dependent. Whenever the vectors are linearly independent, they are not linearly dependent. Whenever the vectors are not linearly independent, they are called linearly dependent. Simple. So, we can bifurcate the vectors into two sets only, linearly independent or linearly dependent. If not, vectors are not linearly independent, then simply they can call it as linearly dependent. If they are not linearly dependent, we can call it as linearly independent. And this terminology is useful only for what? Vectors, not for points. So when can I say the vectors are linearly independent? You take any linear combination of the vectors which is equal to 0 bar, and you prove that all the scalars must be equal to 0. Then simply the vectors are what? Linearly independent. And if the vectors are not linearly independent, then simply I can say that the vectors are what? Linearly dependent. In a linearly independent, what to do? What to prove? All the scalars must be 0. If at least one scalar is non-zero, automatically the vectors becomes what? Linearly dependent. Automatically the vectors becomes what? Linearly dependent. That is the simple litmus test and simple difference between Li and Ld. Li means linearly independent. Ld means linearly dependent. Okay. Now, my friends, suppose A bar equal to 3i plus 2j plus 5k. This can be expressed as what? What does it mean? It can be expressed as a linear combination of ijk. Here, A bar, ijk form a linearly dependent set of vectors because I find the scalars 1, 3, 1, 1, minus 3, minus 2, 5 such that the linear combination is 0. That means there exist scalars, not all 0 such that the linear combination is 0. Therefore, the vectors are what? Linearly dependent. Whenever the vectors are linearly dependent, simply I can say that the vectors are coplanar. LD vectors are always coplanar. This already we told and we discussed in our previous video also. Please go through them. Okay? Linearly dependent. Suppose ijk are linearly independent vectors. I want to prove whether what is about ijk. They are basic questions. We may expect very good questions in more than one answer type of problems. See, if I have considered this linear combination, this is the true only if k1 equal to 0, k2 equal to 0, k3 equal to 0. So I have considered the linear combination like this, and it implies that each and every scalar must be 0. So what can I say about ijk? They are what? Linearly independent. So ijk, the vectors are always Li. They are not Ld. They are not Ld. That's why ijk are what? Non-coplanar vectors. That means linearly independent vectors are always non-coplanar. Li vectors are always what? Non-coplanar. Non-coplanar. Okay. So Li and Ld is applicable only for what? Vectors, not for points. Clear? Now, if two vectors A bar and B bar are Ld, That means linearly dependent. That means what? Two vectors are LD. Actually, don't since they are vectors, no problem. A bar is parallel to B bar. So if I am using the terminology for two vectors, nothing but what? LD means what? They are, don't say that they are coplanar. They are what? Parallel. They are parallel. That means their cross product is 0. Their LD, the linear independence of A bar and B bar, that is what? Linear independence of A bar and B bar. Conversely, if A bar cross B bar not equal to 0, then the vectors are Li. So, if I am talking about linearly independent and linear dependence of two vectors, you just find the cross product and prove the cross product is 0. If the cross product is 0, simply the two vectors are LD vectors, otherwise they are Li vectors. Okay. Now, if box product is 0, that means if the vectors are coplanar, simply the vectors are LD. If the box product is not 0, simply the vectors are Li. Okay, my friends? Coplanarity of vectors. This already I told. When can I say the vectors are coplanar? When can I say 4 points are coplanar? Already I told. Now here, coming to the points. Suppose 4 points are given for me with the position of vectors A bar, B bar, C bar, D bar. See here position vectors A bar, B bar, C bar, D bar. 4 points. Whenever 4 points are given, I need to talk only whether the points are coplanar or not. Don't say that whether they are collinear or not. Whenever more than 3 points are given, we talk about coplanarity. Whenever 2 points are given, we need to talk about, they are always coplanar. They are always coplanar. Whether they are collinear or not, we need to talk. Okay. So here, see, my friends, 4 points A, B, C, D with the position vectors A bar, B bar, C bar, D bar, respective are coplanar. If and only if there are scalars X, Y, Z, W, not all zeros such that X A bar plus Y B bar plus Z C bar plus W bar, W D bar equal to 0, where X plus Y plus Z plus W equal to 0. The same funda, again, we have applied for solving the problems in complex numbers also. See the relations between complex numbers versus vector algebra. Several things, the same result we have applied even in complex numbers. That's why you please practice. This is about the condition at which the 4 points are said to be coplanar. When can we say the 4 points are coplanar? You take the linear combination and you prove that all the sum of all the scalars equal to 0. Based on this funda also, we may expect very good questions. But please study and by heart these results. It's a must for you. Now, reciprocal system of vectors. See, if A bar, B bar, C bar and A bar dash, B bar dash, C bar dash, not caps. These two set of non-coplanar vectors are such that their dot product is 1. Then we can say that the two system of vectors are called a reciprocal system of vectors. Okay, reciprocal means what? If reciprocal of 2 is what? 1 by 2. Reciprocal of 1 by 3 is what? 3. That means product is 1 in real number system. Like this, in vector algebra, two system of vectors A bar, B bar, C bar, A bar dash, B bar dash, C bar dash are said to be the reciprocal systems. Their dot product is 1. Their dot product is 1. So if I know A bar, B bar, C bar, I will find A bar dash, B bar dash, C bar dash with the help of this one, because with the help of this one only A bar dot A bar dash becomes 1, because this is what A bar dot. What is A bar dash? B bar cross C bar by box ABC. This is box ABC, numerator by box ABC. This is what? 1. Again, the same question several times repeated in advanced IIT JEE old papers. You just verify the previous IIT JEE papers, you will find these kind of questions. But in IIT JEE examination, they never concentrate on the names and the terminology. They asked the question, okay, what is about if A bar dash is equal to this one, B bar dash is equal to this one, C bar dash is equal to what is A bar dot A bar dash, or A bar dot C bar, C bar dash, like that questions only they asked, and same thing we may expect in the coming examination also. Hope you enjoyed this video. If you like this, please share and subscribe my channel, and please don't forget to press the bell icon. There you will get the continuous notifications of the coming lessons. Thank you.